Okay, so hopefully you guys are clear about that. Wednesday, you still have work to do, the 4.8 notes, um, and then deal well on it. And then Thursday, when we're back together, we'll finish up the unit notes. And then we're going to go into some like practice with it. And then you guys will I can decide if I'm going to have you guys progress check probably on Monday, and then test on either Wednesday or Thursday. I'm debating moving the test back one day. Next week. Yeah, I think I'm going to put it to next Thursday just because I want to spend an extra day on El Nino and La Nina. They tend to be big concepts throughout the year. So I think I might spend an extra day doing that. Any question about the schedule?
No.
Okay. So I'm going to give you guys like a few minutes, where is it? Week 6. To do this warm-up question right here, and then we're going to talk about it. So take a few minutes to do it. No, those don't come out till October. We have like a week off in October. That's when they come out.
Okay, submitted it.
Awesome. Gonna give about one more minute. Typically it should be done that day, but I tend not to check it until the weekend. Okay. I have 6 people that have finished. Bless you. Alright, I have Jalen, Jesus, Leland, Javed, Dante, and Isaiah Shivers. I have your answers in. Oh, and Niaja, and Keenan. I don't know if I said your name yet. All right, so the Hoover Dam is the largest dam in the United States, built on the Colorado River to supply hydroelectric power and flood control. Which of the following best describes the downstream environmental effect of the Hoover Dam in the Colorado River watershed? That was too many words for me to say. I have 9 of you. Yeah, I got you, Devon. All right, I'm going to scroll over. All right. The correct answer, which most of you got, the damming of the Colorado River led to a change in stream flow, preventing river water and sediments from reaching the delta area. Do you guys know what a delta is?
The delta isn't that the place where a stream enters into a river?
Look closely, Lind. It's where a river would enter into a large body of water, like a bay or an ocean, and you tend to get a whole lot of like sandy deposits, or sandbars even. And that's just where it's going really fast through the river. It hits that big body of water. The water slows way down and drops all the sediments out. Not all, but a lot of them. And it's usually a very biodiverse area. So therefore, sediments not reaching that front to keep it that way. Building land tends to negatively impact it. All right. So today we're going to go through the 4.7 notes. I forgot to pull them up though, so please give me 1 second. The link? Which link? Oh yeah, that's not a link because they're all up here. So you guys can access it. I just put all of them up at once for people that wanted to work ahead. And then I just write that we're doing it down here. So none of them are clickable. All right. Solar radiation. Here's a 1-sentence summary for your watersheds. It's like a really big bathtub, if that helps you to remember. All right. Security alert. What the hell is this? I have no idea what that was all about. All right. Let me pull my teams back up. All right. So we're talking a little bit about solar radiation and the Earth seasons. What do you guys know already about Earth seasons? Somebody give me.
They vary in intensity.
Okay, actually, you are probably more right than you realize, or you remember your Earth science class. They vary in intensity. Absolutely. I do like this little graph. It's kind of a graph. So if you like hot and humid, you should live somewhere over here. If you like cold and heat, you should live somewhere over here, like Kansas City, which you'll probably never catch me in. And we have all these different places with these different climates. Oh, we have a new person. All right. So how many ways does the Earth move? Does anyone know? How many different ways?
Ways?
Yeah. How many different ways does the Earth move?
2?
Yeah. No, not too many to count. Devon's got it. He's correct. It is 3.
Sweet.
It moves in 3 different ways. If I could get my mouse to work, that'd be great. All right, so there's a few things that factor into the amount of solar energy at the surface of the Earth, which is directly correlated to plant productivity. We'll talk a lot more about that next unit. But you guys should know at least your like food chain, you have to have a lot of plants in order to sustain all the bigger animals, the omnivores, carnivores, and herbivores. And then the solar energy is just that energy coming from our sun. So those three types, I'm just going to put it all up here. All right. So the first type is rotation. You're moving one rotation every 24 hours. So rotation is a day. Your revolution, so you have rotation where you're just spinning. Your revolution moves you around the sun. So you're spinning while you're moving around the sun. And then the tilt of your axis, it's also called precession. And it wobbles. If you think of like a little top that you could spin, your axis kind of goes back and forth. It actually goes up, that's a typo, it should say up to 24.5 degrees. So between 18 and 24.5 degrees, the Earth changes a little bit. This is what's responsible for extensive heating eras through Earth's history. It's responsible for ice ages. We have 2 out of 3 of these working against us right now as far as global climate change and warming, all of that. So it might not seem like a whole lot of movement, which galactically it is not, but it makes a huge difference on just a single planet. And the fourth one up there, I didn't highlight as one of the 3, but as far as a lot of stuff we're concerned, atmospheric conditions actually kind of change how things go here. Hey. So that's just kind of like, it's not considered one of the 3, but it does affect the amount of solar energy, especially when we talk about like ozone layers and stuff like that. Is there?
Yeah, so I just have to go get my.
All right. Everyone good there? All right. I forget that if I change it on my computer, it doesn't change up here. All right. So what causes seasons? I can tell you this bottom bullet right down here at the bottom is the biggest misconception about seasons. Summer is not when you're the closest to the sun. All right, winter is not when you're the furthest from the sun. It has absolutely nothing to do with our distance from the sun. Our orbit actually changes over time from circular to elliptical, and then it keeps bouncing back and forth. It's actually the tilt. So if you think of, if any of you guys have ever had like a really good flashlight that produces a lot of heat, so probably a really old flashlight, and you put it right on your skin, you can feel your skin heat up. But if you angle it a little bit, it doesn't warm you as much. All right, so the sun does the same thing to the Earth. So if it can hit, since light only travels in straight lines, if it can hit direct on, like it typically does around the equator, it's going to heat up a lot faster than it is at the poles because it hits them at an angle. Bless you. So summer has the greatest period of solar radiation in the northern hemisphere. So right now we are about to head into winter. What is Australia about to head into? Yeah, they're about to head into summer. So keep in mind, most of the stuff we talk about is generally going to be geared towards the northern hemisphere because that's where most people live. So our summer period is when we are tilted in the northern hemisphere towards the sun. So it rises higher and it stays above the horizon longer. That's where we have our longer days. What is it? The rays strike the ground most directly And then when it's opposite, when it does it at an angle, that's your winter time. You're actually closer to the sun during winter. Perihelion means you're close to the sun. That's the closest point. Aphelion is the furthest point in your orbit that we're away from the sun. Hopefully that's maybe a little bit of review. You guys know what equinoxes and solstices are? No?
The equinoxes, yes. Solstices, not so much.
So equinox, you have a fall and a spring equinox. So that's when you've got equal amounts of daylight and nighttime. Equinox equal. And then your solstices, like in December and June, which are your start of winter and start of summer, those are the days in winter. It's going to be the shortest day of the year. In summer, it's going to be the longest day of the year. So those are your equinoxes and your solstices. So tilt of the earth, this kind of, if the sun was in the center, right, and sunlight can only travel in straight lines, it's going to hit the southern hemisphere very extreme, and it's going to bounce off most of the northern hemisphere. So that's our December solstice, when the northern hemisphere is in winter. And then opposite for the June solstice. So hopefully that picture helps a little bit. I feel like this is a very visual part of the unit, and I have nothing to help. All right, we're going to attempt and see if I can get my video to work today. I meant to look for another Coriolis one because Leland, stop. Okay. Oh, it would help if I hit enable content, probably. I have been talking way too much today. Oh my gosh. This is going to freeze up my computer. Come on.
Ah, the seasons.
There.
It gets cold in the winter. Flowers bloom and...
Oh my god.
Yeah, the video's not working.
Yeah, it's working on one of my screens, so I'll try this. It's being really special. My computer's been bad all day. Alright, sorry, I can't touch anything on my other screens, I forgot. Maybe.
Ah, the seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth, and there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the Sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now not only is the Earth going around the Sun, the Earth is spinning. Now when you're on the part of the Earth that's toward the Sun, it's daytime. When you're on the part of the Earth that's away from the Sun, it's nighttime. Now the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the Sun, it's summertime there. So when it's summertime here in my laboratories, on the other side of the world, it's wintertime. In places like South America and Australia, you build your shoes on time. Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the Sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because Earth's axis is tilted. That's the reason for the seasons. Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale. The one at the South Pole is right around the room temperature mark. The ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on, whereas at the poles it's just barely grazing by. And if it's somewhere in between, well, it's somewhere in between. See, it's not that the equator is closer to the heat, it's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp just barely grazes by. I mean, the energy from the sun. Thank you for joining me.
We notice, though, that the axis about which the Earth turns is not straight up and down. It's tilted to one side, at an angle of 23.5 degrees from the perpendicular. This has a lot to do with why we have different seasons, as we shall see.
Let's say that this plastic globe of science is like the Earth. And we have two solar panels now. Now, solar panels convert light directly into electricity. So right now, these two panels are making enough electricity to run these two little motors. Now, right now, both motors are going about the same speed. Now notice we have one panel in the northern half of the Earth, the northern hemisphere, one panel in the southern half of the Earth, the southern hemisphere. They're both receiving about the same amount of light. But let's say it's summer here in my laboratories in the northern half of the Earth, the northern hemisphere. That means that the Earth will be tipped toward the sun, not like look, the motor in the southern hemisphere is just barely moving. The motor in the northern hemisphere is spinning like crazy. Now let's say it's 6 months later, and the Earth is going around the sun so that its axis is tipped this way. Now look, it's reversed. The one in the south is going wild, and the one in the north is slowed way down. So what that means is, this panel, the southern hemisphere, is receiving more light, more energy from the sun than the one in the northern hemisphere. It's just like the Earth's seasons, right here with the solar panel plastic globe of science.
Using a flashlight, you can see to yourself that direct rays are concentrated on a smaller area than flash rays. This is why direct rays produce more heat.
I'm sorry, but maybe it's my age, but who doesn't love Bill Nye? All right. This should be the next slide, I hope. So weather is a set of short-term atmospheric conditions. A lot of people tend to confuse weather and climate. Climate is long-term. Weather is the day-to-day, easy type of stuff. Short-term atmospheric conditions, we would be looking at temperature, pressure, moisture content, which is humidity, precipitation, sunshine, cloud cover, wind direction, and the speed of the wind are all different types of short-term atmospheric conditions. All right, so after weather comes climate. So that's an area's general pattern of those atmospheric conditions. So it's still a lot of the same variables like temperature and air pressure, wind speed, direction. but it's long term. We tend to not look at the term climate until like 10 to 20 years of data have been collected in that area. So weather's day to day, or even comparing it to last year or the year before, um, like this winter is going to be a wetter winter than the previous one, type of thing. That is weather. Climate is overall general expectations for the area, ranges, things like that. Everyone good? All right. And lastly, climate is what you expect, weather is what you get. So nobody expects a bomb cyclone to be hitting um, Colorado consistently every year. I mean, I've been here since like 2008. That had only hit once. So that is definitely weather. But climate is what we see year to year and expect it to be, and it's normal, like today. Hi. Um, kind of. All climates have seasons. Every single climate has seasons. But those averages can um, help kind of dictate what to expect during that season. Like where I'm from, I can start planting and growing vegetables in like March. If I were to do that in Colorado, I'd be broke and hungry because you can't start doing that till like the beginning of June. So while it's still the same season, it's still spring season, and just from Washington State to Colorado, there's a very different climate. Does that make sense? Okay. All right. So if you've got any questions on watersheds, definitely ask them now. Otherwise, I'm going to let you guys, give you guys the time to work on the DOL today and yesterday's if you didn't do it. So you have one today, DOL number 7, and DOL number 6 from yesterday if you didn't do it. So I'm going to give you the time to do that. It's on AP Classroom. And you have about 10 or 11 minutes. Yeah. What? There's a setting for that. I have to think. It's been so long since I've looked at it. I would have to play around with it. Weather and then climate.
Unfortunately, I can't. If you want to write it down, I'll like it's something. But otherwise, that's the only way I would go.
Bless you. Again, but not a third time. As long as you're really quick. Sign in and out on the door.
Sign out.
Yep. On the door.
Oh, okay.
Yes. You're welcome. Gets you away from all the concrete.
I'm pretty tired. I'm gonna go home.
Except for you actually have classes today.
I know. This is like when I actually have class. And I gotta go to work after. I don't want to go to work. We always have this one guy that comes in. He gets the exact same thing. If we don't remember, he gets mad at us. She's like, you should know.
You're a new person?
I don't even know.
Yeah.
When I was new, he was contributing and he had to say what he wanted. It's okay. When they do come, I'm gonna make sure. I'm gonna tell everyone.
Did it work, Devon? Okay. So as you guys are wrapping up, the question, none of you guys are logged in on Teams, but I've put out to them is two different questions. One, how do you feel about doing labs minus the whole communication factor that was not your guys' fault? I'll pre-plan for that next time. But how do you feel about doing the labs when you're split up like this? And then,
I can still submit it to you.
huh?
I can submit my part of the group.
Yeah, that's fine. And then the second question is whether or not you'd be interested in doing like voluntary, because we're not allowed to do field trips. And this is the one class I make sure gets field trips usually. But like going to like Garden of the Gods or something and walking through different biomes, or voluntary ones that would be like on a Saturday morning or something. So if you're in class, if you want to shoot me an email or chat, I don't care, either one. I put it in the Teams. Leland suggests no more labs, but maybe doing labs as part of the field trip, which is totally possible. Labs in a normal setting when we're all here is like so much easier. And like I said, because they still have to do something.
They can do it when they come.
Yeah, but not all of them do. We have like 7 e-learners in this class, so that never comes in. Not do what, Naija? Group work? And
I'm
yeah.
so glad we did that.
Yeah, I agree. Okay. All right, so it's just about to say the bell is about to ring. So remember, you're not coming to class tomorrow. It is online only. It's notes, warm up, DOL. Bye, Keenan.
I could actually leave.
There is tomorrow. Yep.
Because I did.
Bye, Miss. Have a
Bye.
good day.
You too. Oh yeah. Yeah, there is. It's quick, easy stuff, and then we'll just kind of rehash it on Thursday. All right. Have a good one. Huh?
I just said it. Naomi Alejandra, please come to the front office. Yeah, Naomi Alejandra, please come to the front office. I shared it with you.
Okay. Yeah. Like I said, I know it was not your guys' fault for not being able to communicate effectively. So, thank you. There.
I'm in your class.
Oh, are you? You're in my class now?
Yeah, I would love to be in your class again. I would be so happy to be in your class again.
It was